Hi everyone. Today we will be working on the rod guide assignment. In this assignment we need to draw the three orthographic views. We need to dimension them and we need to draw a 3D model of this object. I have the three orthographic views ready here, dimensioned, and here in this part we just need to make sure that we have correct unit format. Here, as we can see, the unit format is fractional and the fraction format is diagonal. So in order to change the dimension style, we're going to type in D to access the dimension style manager. While the standard dimension style is selected, we're going to select modify and select the primary tab, unit format, select fractional. Fraction format should be diagonal. So that's what we need to change. Also, we have to make sure the text height is 1/8 or 0.125. And the rest should be okay. So click OK, set current, close. Now we want to demonstrate how to draw the 3D model of this object. So the 3D model, the front part of the 3D model will have this shape. So here if we copy the outline of the front view and paste it here, then we can work on it to create a 3D model. So let's turn off some of the layers, such as the center layer, dimension layer, and the hidden layer. That way we can select the object quickly. So now press and hold Ctrl C and select the object, enter. Before pasting it here, we want to change the view to front because right now we're in plan view. So top view is the same as plan view. And we want to change the view to front. Change the view to front and then paste. So Ctrl V to paste it here. Now we don't need these two lines. We can erase them. And here we have individual lines. Okay. First we need to create a region. What is a region? Region converts an object that encloses an area into a region object. So we can type in REGION, region, enter, select objects, enter. Now if I go with cursor on this object, we see everything will be highlighted as one complex shape. Okay, now we have created the region. We're ready to extrude it. Let's select the southeast isometric direction indicated on the handout, assignments handout. And now we want to extrude. So the extrude command, EXT, enter, select, enter, and here we need to enter the depth of the object, which is 1 1/4, so 1.25, enter. So extrude creates a 3D solid or surface by extending the dimensions of an object. So an extrusion is a shape that has been given thickness. So at this point, right now we're using the 2D wireframe visual style. We can select the conceptual visual style so we can see better what we are doing. But when we are finished and we want to create the viewports, we have to make sure to have the 2D visual style for the orthographic views. Otherwise, we'll have some weird dimensions. So here, we want to draw the cylinders and subtract them from this object. Before starting, we should set the UCS on this face so we can draw on this face. What is UCS? UCS sets the origin and orientation of the current UCS. So actually, UCS stands for user coordinate system. So user can define the orientation of the coordinates. Here we can type in UCS, enter, and then F for face, and set the UCS on this face. Okay, then enter an option, accept, so just enter to accept it. So now X, positive X is this direction, positive Y is this direction, and Z is this direction. So we can draw on this face. So one more time, UCS, enter, F, enter face, and then click here to set the UCS on this face and accept it. Actually, we wanted X direction be here and Y be this direction. So now we have to locate the center point for the cylinder. So L, enter, click here. Look at the drawing. We have to go 0.5 in X direction and 0.5 along the Y direction. Enter, and then draw a cylinder, CYL, enter, click on the endpoint. Diameter of the cylinder is 7/16, so D, enter, 7/16. And specify height, we just click here because we're going to subtract this cylinder from the object anyway. So any height larger than 1/2 the height of this object would work. And now we are going to use the free orbit, which rotates the view in 3D space without constraining roll. Click on free orbit to rotate the object a little bit so we can work on this face. And now we're going to draw a line from this corner, 0.5, and go draw a line in Y direction, 0.5, then cylinder, click on the endpoint. Diameter is indicated 7/16, that's the decimal equivalent. Enter and click here, and we can carefully erase the reference line, also this line. And we're going to subtract the cylinders all at once. So again, free orbit to orbit the drawing, to orbit the object. And now we want to draw on this face. So UCS, enter, F, enter. This time we're going to click here to set the UCS on this face, enter. So now we have to find the center point for the cylinder. If we draw a line from this corner and 5/8 0.625 and go down. The distance is 11/16, so 11/16. Then cylinder, CYL, enter, click here, and the diameter of this cylinder is 1/2, so radius would be 0.25. And since it says 2 times diameter 1/2 inline, so it means both cylinders will be the same size. Click and erase the reference line. And now subtract, so we're going to rotate the object a little bit so we can select all at once. SU, enter, to subtract. So subtract combines selected 3D solids or 2D regions by subtraction. So subtract from the object, so first we're going to select the object, enter, then select the cylinders that should be subtracted from the object. Okay, and free orbit to see all sides of the object, and they're fine. And now we're ready to create the chamfer, and then we'll be done. So CHA, enter, click on this edge, enter distance. Chamfer distance is 3/8, so I have it already. So enter, click here, enter to create a chamfer, and we do the same thing here. So enter to repeat the chamfer command. Click on this edge, enter. Chamfer distance is 3/8 or 0.375, enter. Second chamfer distance is the same, enter. Click on the same edge, enter to create the chamfer. Now we're done with this object, and we have both. We have the orthographic views, we have the 3D model. Okay, and now we're going to switch to layout 1. Here we need to create 2 viewports. So we are going to go back to Home tab and select the viewports layer. Then type in MV. So MView creates and controls layout viewports. And from the given options, we can either select 2 to create 2 viewports, or manually create 2 viewports. So here, without selecting any of those options, we can click here and drag a box, enter, and create a second viewport. Then we want to work on this viewport. Just double click inside of it, and view should be top view, visual style 2D, wireframe, and scale should be 1:1. So here we're missing the dimensions, center lines, and hidden lines. We're going to go back to Home tab and turn the layers back on, center, dimension, and hidden. So 1:1, then lock it. So when we zoom in, zoom out, the scale doesn't change. And now we'll be working on this viewport. Here we want to show the 3D model, which is right here. So view southeast isometric view, and then scale 1 to 1. So I cannot find it. It's right here. Scale 1 to 1. It keeps hiding. And also, if this UCS does not let us see the object, what we can do is turn off the UCS icon. So if we just type in UCS icon, enter, and then right now it's turned on. If we type in off, enter, it will be turned off. So now we can select scale 1 to 1, and it looks good. So we're going to switch to paper space, home tab, turn off the viewports layer, turn off, and change the layer to 0 when you are finished. So the last step is using the ATE command to edit the title block. So title of this drawing is Rod Guide, drawn by class ID CAT2170, class time, today's date, scale is 1 to 1. Drawing number 12, say OK. And then this drawing should be printed on B size 11 by 17 and folded and turned in. Also, we need to submit this drawing to Blackboard. Alright, we're done with the Rod Guide drawing. Please let me know if you have any questions.